Okay, first go ahead and open the new shell file that I have made available in Blackboard. Okay, so this is the new one, and I have already completed the first sheet, which is the same topics that we covered last week. Now this time we're going to start with the second sheet, normal probability. In a normal probability distribution follows a bell-shaped curve, something like this. But in Excel, there are 4 functions related to normal probability. There are 2 functions, like these two, are used for finding the normal probability given an x value. Okay. So if x is known, you use these two, either of the two, and that will give you the cumulative probability. Like for example, if this is x, the function will give you the probability that is x or smaller than x. Now the two other functions are used to find the value of x given a normal probability. Suppose you are given 80% or 90% as the probability. Okay, what is the x value corresponding to that probability? Yeah. That question is answered by these two functions. Notice the ending. For probability, the ending is dist. For finding the x value, the ending is .inv. Okay, let's look at the example now. Let us assume that we are selling some tickets for some event, and X is the number of tickets we sell. And suppose if the number of tickets that we're going to sell is going to follow a normal distribution. Okay. And in order to find probability about how many tickets we will be able to sell using the normal probability distribution, we have to have these two values, the mean of that probability distribution and the standard deviation. Okay. And in this problem, these two numbers are given. We are given that the mean is 12,000. We are given that the standard deviation sigma is 8,000. Okay, now let's look at the questions. Okay, now we want to find, given these parameters, what is the probability that we will sell no more than 8,000 tickets. So which means that 8,000 or less. Okay, that is the cumulative probability. For example, here this value is 8,000 and we want the probability that we will be able to sell up to 8,000 tickets. Okay, that's cumulative probability. So what we want is x value is 8,000. Okay, let's type that there. Okay, and let us format it and align it properly. Okay, then the probability that x is less than or equal to 8,000 is given by the norm.dist function. So let's type equal to norm.dist. Okay, so now here are the values that we have to provide to the function. The first value is x, so which is 8,000. The second value is mean, okay, so that is that cell. The third value is standard deviation. Then we have to provide one more piece of information, and that is whether we want the cumulative probability or we want only the probability mass function. Probability mass function is simply the height of the normal curve at that given point. We don't want that. We want the probability, and that will be the case almost always. I can't think of any situation where you will want the height of the function. We will always want the probability. So it should be either you can type true or you can simply press the number 1, which is equivalent to true. Now that's it. That will give us the probability, and we can go ahead and format it a little bit. Okay. Now that is using the first function norm.dist, where we give the value of x, value of mean mu, and value of sigma, and out comes the probability. Now the second way that we can accomplish the same result or find the same answer is to first convert the x into z. Sure, you have done this in your stat classes, and we use this formula for converting x into z. Then we can use norm.s.dist. That s here stands for standard normal. So first we find the z, so that is equal to x minus the mean mu divided by the standard deviation. Okay, again, let's go ahead and format this, align it properly. And now the probability is you use, since we are now using, since we are already found the z value, we're going to be using the z value. We use norm.s.dist, and now we give the value of z, and once again, whether we want the cumulative probability or simply the height of the normal function, and as I said just a minute ago, we always want the cumulative probability. And of course we get the same answer because these are two different ways of getting normal probability, cumulative normal probability.